Okay, well, welcome to the SUSECON Digital 2020 event. Thank you for joining. I hope you get some useful information out of this and you have some fun. This is an introduction to Kubernetes, which is a hands-on lab. Okay, to be totally honest, my hands-on will be on in the lab doing things and demonstrating things and whatnot for you. But hopefully with the information that you get, the experience that you gain, and also the material that's at the end, you could probably download all this and put it up in your environment and run through the same thing and learn as well. Next, I'd like to do a call out to Alex Arnaldi. He is one of my peers. He is a software-defined infrastructure solutions architect. He's been with SUSE for about 1.5 years now. He is heavily invested in Ceph and Kubernetes and OpenStack previously. And he did an outstanding job, and I want to give him kudos for this. He set up scripts to automate the deployment of this infrastructure, and think about having to do this across n number of devices in a few minutes between sessions. And we did that, and we set up a Kubernetes environment that you can use, and you will be seeing a bit of it and what it was set up throughout the lab. Now, as for me, my name is Brian Gartner. I've been with SUSE for over 7 years. I work on our alliances team as a senior technology strategist, which means I work with a lot of our partners, whether they're hardware partners or software partners or embedded partners, and spend all my time doing reference architectures of our solutions on top of theirs or underneath theirs, depending if they're a software partner. And with that, let's go on to the next slide. Okay, let's go over the agenda of what we're going to cover. So we'll do a brief introduction of the technology, just to basically an overview context. Then we will have 3 labs, and I've kind of named them in the notion of learning how to drive a car, or thinking about your teenager learning how to drive a car. So starting up your engine, turning your signal on, trying to get on the highways, and then cruising down the highways once you're comfortable with all this technology. Then we'll finally do a wrap-up. Okay, let's go on to the next slide. And I'm going to ask you, even though it's not interactive and whatnot, but just some questions to think about. Who in the group that's watching this, have you used or created or deployed containerized workloads? My guess is a significant number of your virtual hands would have gone up, saying that, yeah, I've created some, I've used it, it could be just on my laptop or something like that. How many of you have interacted with Kubernetes before? And I'm still expecting a good number, but maybe a smaller number of virtual hands on this one. But I would encourage you to start looking around more and finding all the places that are using Kubernetes. You're interacting with it all the time, especially if you've got a mobile device or a system that's attached to your TV, or an application that's on your TV, and there's some kind of software as a service. And there's other places too. We'll go over those in a sec. Who has created or deployed or managed true microservice-based applications on Kubernetes? Again, I'm expecting each one of these questions, the number of hands are slightly less, but hopefully there's a few of you, and hopefully this is still useful for you. Maybe you've only had to do it initially, and you're just trying to ramp up and learn, because it is a very de facto standard coming out. Next, how many of you have been directed to actually do some of the above? And my guess is the answer of that one is a huge amount, and people are trying to ramp up and learn in this space because it is becoming something that's very, very valuable. Okay, on to the next slide. So what is Kubernetes? What is that technology? First of all, it is a very portable environment. It's very extensible. It is open source, okay? And if you were to look and follow that upstream community, you'll see that they release a new version about every 3 months. The good news is there's lots of features that come in, it's growing, it's getting more and more capable and more flexible and whatnot. Bottom line, just in a nutshell, it's used for managing and orchestrating containerized workloads and services, okay? That's really what its job in life is. So you can provide a declarative configuration of what you want things to be like, and it'll manage that in the best way that it possibly can to keep it in that state. And it is very automatable. It's very You can script things, you can interact with things, and you can just say, I want it to be like this for the amount of time, and I want to do a tweak, and you can do that tweak, and that happens, okay? And again, it's all about that managing and orchestrating. If you want to know where the name came from, it is a Greek. It came from Greek. It does mean helmsman or pilot, okay? And if you look under the covers, and this goes back to that question that I mentioned on the last slide, Google actually open sourced this project in 2014. And there was a huge influx of people that wanted to contribute and whatnot because it was based on the technology that was used underneath the covers behind the scenes when you do Google searches and all those things. And they had a decade and a half of their experience, and they just said, okay, we're going to open source this. But now it actually combines best of breed ideas and more practices from the community, and the contributors just keep growing, and things will change over time and get swapped out, and there might be a workaround or an alpha or beta feature in this version, and then the next one, if it gets to the point of that it's testable and reproducible and production kind of grade, it'll become part of the release. Okay, let's go on to the next slide. So what does it provide underneath the covers and whatnot? And these are very important features that it provides. So there are choices of various network plugins in the CNI container network interface, and that's a link and you can follow it. So there's different ways of doing networking, not only on the infrastructure itself, but within that infrastructure of all of those microservices that are running. And each of them has advantages and disadvantages and trade-offs and all that classic engineering, especially software engineering. In the same context, there are various storage backend plugins, and that's the container storage interface. So if you have a certain kind of interface or a certain kind of device that you want to connect to a Kubernetes cluster, you can, to provide persistent data store. Chances are really good that that probably already exists, and if not, the community is welcome to take that contribution, look at it, and then work on it and make it production grade. In essence, though, one of the real values of Kubernetes is it allows the ability to do a very resilient infrastructure. and what that means is it's self-healing. It's scalable. So if you were doing a microservice kind of shopping cart thing and it's coming up on that huge shopping holiday time period like called Black Friday, you can just have it automatically scale up if you want it to, based on the workload and the amount of requests that are coming in or whatever. And then when it's a few days later, a week later or whatever, they notice the workload goes down and it can scale back down. That's the beauty of it. You can make a very core set of functionality work, and you can scale it as you need to. And it could be at any number of the layers of a microservice or architecture. There's certainly things about service discovery, load balancing, and you can see how that fits into that healing and resilient thing. So you can have a load balancer up front, and as you add more and more web server front ends, that load balancer can just hand out requests to those guys. Okay, and it could even be load balancing in terms of like a database server, if that was maybe more of an internal thing that's being poked by that new workload that just popped up. It can say, oh, we can load balance all the read requests to a mirrored copy on this database microservice over here, and then all the write requests to go to another one. You can do all kinds of really cool things. Not only that, you can do automated rollouts and rollbacks, and this was where the cloud native mentality really has pushed us forward. The ability to, because microservices are based on containers, which are very small, lightweight typically, and you might want to just rev that one container to pick up a feature or to fix a defect or whatever. You can actually do that kind of a rollout, and you can do it in a widespread fashion. You can just say, yep, fix them all. Or you can do it in a green-blue kind of scenario where you only roll out a percentage of them, and you make sure and you look at logs and you go, yep, it's behaving really well, go up to the next level, Okay, now we're at 100%, cool. And likewise, if somehow you made a mistake and things didn't work, you can roll back. You can go back in time. You can just retro roll back to a previous version of it because you knew that one was working. You knew the new one wasn't, so just roll back. And you can do it in a graded format like that, or you can just do a widespread one, okay? And there are also things like secret and configuration management. So you don't have to embed like users, names, and passwords within a microservice and make those very vulnerable, but you can put them somewhere else and you can pass them as needed to the microservices that need them, and they can query it, and those are all encrypted and all that good stuff. And you can also do configuration management. So let's say that you want to leverage, what your peer developer did. You can certainly do that, and you might want to just tweak it because he's a developer, but I'm the test engineer, so I just do it I do it almost identical, except maybe I did it in a different IP space or a different context or something like that. And I change one variable and I deploy a parallel world to what he has that can run. Okay, let's go on to the next slide. So let me give some examples of what Kubernetes is not. It is not really a limiter of types of workloads, and I'll say this in one context really, that if you're a true cloud native 12-factor kind of person, you always said that the answer is everything should be stateless. Well, we all know that that's not completely usable. That's very viable for some parts of an overall architecture, and you should leverage all those techniques and all those technologies and whatnot to do that. But you can also do stateful ones. In other words, like I mentioned on the last slide about a database or something. Yes, I can have a persistent data store that it can access, and all I'm running is the application in the microservice that accesses that database backend. Okay, that persistent store or whatever. So once you go down this path, you realize things like analytics for data processing, for machine learning, for AI. Any of those things can do it. And so Kubernetes doesn't limit you from doing it. It basically just says, I'm going to orchestrate what you tell me to try and do. All right. It's not really a deployer of source code by itself. Okay. It assumes that that container image is sitting there, and you told me to deploy it in this fashion with this name or this label in this environment and do these connections and whatnot. It's not necessarily the leveraging of that part of it where it's the CI/CD, the continuous integration, continuous deployment, all the way from the source code. But it can be completely buckled into that. So in an application build factory, Kubernetes is the target where all that happens. So you can create a build process for containers that utilizes Kubernetes and then puts that container image in a registry for the next thing to use it to orchestrate it as its deployment. All right. And it's not a limiter in choices of language APIs. Okay. There's so many ways that you can interact with, and it doesn't put a restriction and say, if your application is not running C++, I can't do anything with it. It doesn't matter, because again, the goal of it is what's the microservice, what's the image underneath it, and what are the APIs that it relies upon and provides. That's really it. Plus, it doesn't limit you for logging, right? It's pretty easy to go ahead and grab the logs of all of these things that are running. You can do monitoring, you can do alerting, you can do configuration management like I talked on the last slide. So the choices are truly up to you. Again, it is an infrastructure for orchestrating microservices. Okay, let's go on to the next slide. Now what I'm going to talk about is the general hands-on lab logistics that we have for you. Each attendee would have had a dedicated, mostly self-contained lab environment. Okay, there's a local copy of the lab guide with the exercises right on that system. There's some quiz-like questions throughout, and there's pointers all over the place to, if I call out a certain command, there's a link to go read about that command, or if I call out a certain Kubernetes object, there's a pointer to that as well. So you can use this as a very much a learning experience, okay? Each lab is preceded by a brief summary, and we'll do the summary here pretty quickly for the first lab. In general, what we try to do is schedule a finite amount of time to do a certain number of exercises. And then in the next lab, or within that lab, there's also additional or optional exercises, or again, that research that you can go read at. So you can certainly fill the amount of time that we've scheduled for you, but hopefully there's enough time for you to actually do the core exercises. You can go deeper with each exercise, like I said, and pursue even the optional and advanced things. And with that, let's go on to the next slide, and we'll talk about lab number 1, start your engines. So the way we structured this lab environment and the lab exercises is a top-down approach. We wanted to give you something up front that shows you the power of what Kubernetes offers, and then in each subsequent lab we drill down underneath and show you how that really worked. Okay, so in this one, it's an easy push button like thing. If you run one command which launches an application, in fact a whole deployment of things, then you can use that application, then you can stop it and clean it all up, and all while you're simply interacting with Kubernetes, and in this case with one simple command. So let's talk about the specific logistics for this session, for this lab 1. What you're going to do, and you notice in this diagram here, you have a student workstation. That's where this environment is and sitting in front of you. There is a, quote, access node that you're going to log in via SSH. You're going to use one command called kubectl to access a Kubernetes cluster, okay? And literally that Kubernetes cluster could have been anywhere. It could have been on a cloud service provider. It could be on your student workstation. It could be on your neighbor's workstation. It could be in your data center. It could be at the edge. But for this environment, everything's actually running on your student workstation, just letting you know. What you're going to do is interact with Kubernetes, do those things on the last slide. And the estimate is pretty short on this one, just 10 to 15 minutes. So with that, go have fun. Go do lab number 1. Okay, like mentioned in the previous slide, what you're going to do to run the lab environment is you're going to log into your student workstation, and you'll end up in a graphical user interface that looks something like this. You'll notice that the lab guide is over here, and you can just double click and open that. And how you'll interact with the lab for now is you will open up a terminal window like this. You will log into the access node using a command like that that's called out in the lab. And that's how you would proceed on. But for the remainder of this, what I'm going to do is I'm going to actually do a slightly alternative view. I will have the lab guide pulled up in a browser like this. Same thing as what was on the desktop there. I will have a terminal window open like this, and I will log in and do things here just so that there's a bit better resolution. All right, we'll go on to the next step now. Okay, we are in lab 1. Let's go ahead and start the first exercise and the first step. We are on the access node. Let's go ahead and cut and paste this command. And you'll notice a few lines of output proceeded. And you'll see in the lab that there are these callout sections, and there's links to important references and whatnot. So like this is the kubectl command, and that's the information about that with more detailed information. And then you'll notice throughout the lab that we do certain little quizzes and whatnot. So the quiz for this one is how many lines of output did we get from that command? And if you look, looks like we got 7 lines of output. Okay. Okay, let's go on to the next step now. So what you may have noticed is there was quite a few things that got deployed, and if you click on this link, you'll actually see what was deployed. So there is a WordPress application with a MySQL backend and some persistent volumes for the storage of the database. Let's go ahead and drill down into what actually was done. So let's start off with kubectl get secrets. And these are actually what how you create the user login and password for the database and how you let all of the services know how to get there and whatnot. And again, there's details for each one of these commands. So as we go through them, we'll do it. All right. Let's go ahead and look at all the services. And you'll notice in the quiz it was asking how many services are running besides Kubernetes, and you'll see that we have in the services command output we have a WordPress service and a WordPress-MySQL. All right, and if you remember from the deployment side, here's the services information. If you remember that this was actually a deployment as called out up here, let's go ahead and look at that now. And you'll see that there are some that are part of what it is, and there was actually one that's resident, which is the storage class. We'll talk about that later. But you see that there is a WordPress and a WordPress-MySQL, right? And again, those references are available so you can learn more about that. All right, let's look at persistent volume claims, and we will describe the storage information in a later section, but just so you can start to see it and get a feeling for what all you did. You'll see that there's a claim for the MySQL and a claim for the WordPress, so that you can have some stateful information and retain that. Okay. And underneath those claims are also some persistent volumes. And one of the important things is to make sure that they're bound. Okay. And when you're looking at volumes and whatnot, you want to make sure that you understand both of these claims and these volumes and how they're attached to storage classes and all that, but we'll cover more of that in later. And then finally, what all is actually running. You know, we're doing everything in a containerized environment, and pods are the granular way that Kubernetes orchestrates containers. So, you know, if you want to look up what pods are and what they are and everything like that, you can. But let's go query and see what's actually running. And you'll see again that there's a WordPress container pod running and a WordPress MySQL running. And so what you should realize at this point, and this was the point of this exercise, is to show you that with one command we launched all this stuff. And scrolling down the lab guide, you'll see that, you know, we as the user did the kubectl command. We launched a service, a load balancer for the WordPress that's connected to the MySQL that has stateful persistent volumes on the back end connected to that storage class. So that's pretty impressive. With one command you can do all of that. Now let's kind of see if we can actually use this thing a little bit. So I'm going to go ahead and clear the screen. And what we're going to do is we're going to do a port forward from one of those pods that's running. Okay, and then we're going to put that into the background so I can continue using the same shell window. And I'll just use a command line browser for now to see if we can get to that thing that's running. And you notice that it is. So we're actually walked into the very first step of a WordPress deployment, and we're in the configuration thing, and we can set that all up and get that running. Okay, and let's see if we can still do this from the web browser from our student workstation. And you'll notice that we're going to go to a slightly different address here, but which is the access node. And you can see that we have that same configuration interface, but in the web view of it versus just the curses. So there we go. We've got that deployed and running, and we'll go on to the next step now. Okay, so you could go ahead and configure this all up and get it totally up and running and everything, but for now we'll just go ahead and quit this browser and go on to the next step. We'll quit that browser and we will bring that port forwarding command back to the foreground and get rid of it. And let's go ahead and clean up this whole deployment. So as easy as it was to deploy and set up, it's just about that easy again with one command to get rid of it all. And we will do a check here in a second and make sure that it really did go away. You recall there was a couple of services running before, and now there are nothing but Kubernetes. So congratulations, you've done a complete deployment of an overall service that covers almost all the stuff that you would normally want to do, and you've cleaned it all up. So you've completed lab 1. And with that, we'll go on and look at some optional and advanced exercises next. Okay, with that all cleaned up and everything, let's go on and look at some optional or advanced exercises if you want to do that. So I'll go ahead and clear the screen. And as you notice, we use this one command, kubectl, but obviously there's probably more information and more things that you can do with it. And you will see there's a lot of things you can do with it, because this is like the key to the Kubernetes interview universe for you. Once you learn this, you can do pretty much everything you want to do with it. Okay, so we did a lot of gets of various components and objects. You can certainly run things, you can expose things, you can create them, you can do all kinds of stuff. You can deal with the cluster itself underneath. And we will go through more and more of this over time in the rest of the section. But one thing that you might want to do is also look at, well, so what was in that lab 1 space? What did that one command reference? And what did it do? So, and one of the things that we did was we did that -k argument, which was for customize. You might want to look that up. That's very powerful. It's a way to put all this stuff in one context and do it all. And so we'll look at that. And in fact, that's the first file, is the customization file. And remember, we looked up secrets. Well, here it is. Okay. And then what other things are going to be called, which are the other files. You'll notice that the other resource file is MySQL deployment, and the next one is that. And just to show you what it looks like, it has all of these properties, all of these things that it does, and it accesses the storage class on the back end. It does that persistent volume claim. It sets up the ports that it's going to use. It tells you what container image to go grab to do this all, how to leverage those secrets. And then likewise, when you look on the WordPress side, all those same things are there too, including those things like those load balancers, persistent volume claims, what am I going to go grab to do it, what port am I going to run, all that good stuff. So that's how all that was done. But if you look, there's just a small amount of text to create all that stuff in one fell swoop. So hopefully that got you very interested in what you can do with Kubernetes. That was just a really lightweight introduction to kubectl, but you've deployed multiple things with a single command. You can get the status of those microservices, and then you can destroy it all again with that single command. So great job. Okay, welcome back from the lab. I hope that went well. I hope that was fun. And I hope one of the things that you realized that was the takeaway of that is kubectl is your new friend. It is the way that you deal with Kubernetes. It is the key to the kingdom. And literally, you have if you learn that one thing, you can do almost everything you want to do with Kubernetes. And I'm hoping that when you did that deployment and you saw what you did and you realized all the things that did happen for you behind the scenes, and you could take that away just as easily, that was really enticing, and it helps you to move on. So with that completed, let's go on to lab number 2. Getting that turn signal on, getting ready to merge. Okay, we're getting our speed up and everything. So what we're going to cover in this lab is the next level of a microservice-based deployment. So we're going to launch it, and we're going to actually explore the components. Okay, we're going to actually see how they were set up, how they were running, how to interact with them a little bit. We're going to scale the application up and potentially down. We're going to update some of the components, and then we're going to delete that deployment again. Okay, so again, this is all about understanding why it's so cool to mess around with Kubernetes and the functionality that it provides. Okay, in the logistics for this session, you'll notice that we've just added a little bit of depth to the portrayal that we're talking here. Again, you're going to go from the student workstation, you're going to SSH to that access node, and you're going to interact with kubectl, that Kubernetes cluster. But what you're going to spend time learning about and messing around with and kind of learning to understand the idiosyncrasies and the capabilities is looking at what are called manifests. Those are YAML files that basically define the state that Kubernetes, you've put on Kubernetes plate to maintain for you. Okay? And you're going to adjust the application deployment. And with that said, this should be like a 30 to 45 minute exercise. Again, there are optional advanced ones at the end. Go have fun. All right, let's go on to the second lab and start the first exercise in that. As mentioned previously in the slides, we're going to explore a little bit deeper. Like the last exercise, we exposed a little bit of the text behind, the manifest behind what was happening with customization. We're going to drill into that some more here. So with this lab and this exercise, you can either click on the link there and see this manifest, and that's the one directly from the GitHub in case it revs over time. But you can also see in this lab environment what's on that system and ready. And then let's go through the quiz and just start to explore this a little bit. So what's the name of the deployment? Well, look, the name, and we're going to do an Nginx deployment. If you're not familiar with that, you should look that up as far as what Nginx is. But how many replica sets? And again, we're going to drill into this in a little bit detail here, but we say we're going to run 2 of these things, whatever they are, a replica set for now. And then finally, what image and version of a container are we going to run? And if you look down here, you'll see that we're going to run Nginx, which is why we called it the part of that deployment, and we're going to run a certain version, 1.16.1. Okay. Okay, let's go on to the next step of the exercise, and this is when we're going to actually deploy it. And we're going to use our friend kubectl to go ahead and deploy it just like before. And you'll see we're going to do a create, and we're going to reference that manifest that we just looked at in that directory by calling it out with the file name. And what you'll notice throughout the lab is I tend to use the full-blown syntax for the command. There are shortcuts like called out there in the tip, but you'll see that we've deployed it, it's created something and whatnot, and in the next steps we'll go through and figure out and drill down into it and discover it a little bit more. Okay, on to step 3, and we're actually going to do a little bit of looking and drilling down and kind of checking those quiz answers that we had before to see if that really did take effect. So first thing we're going to do is the kubectl get deployments, and we're going to call out that name. You can see that it's right up there. Go ahead and clear the screen so it's obvious what we're working on here. All right, and sure enough, there is that deployment that's running. And just like in the other labs, there's links to those references of each one of the commands. Then we're going to look at that replica set thing to kind of get a picture of what is going on there. And sure enough, there is an Nginx deployment, and there are 2 desired. That's what the manifest said to do. There are 2 running, and there are 2 ready. Okay, good news. And if you want more details about what a replica set is, you can look here. Okay. essentially we're basically saying we want this number of instances running all the time, and that's what Kubernetes does for you. And we'll test that here in just a bit. And finally, let's look at the pods themselves and see what's running. And you will see that there are 2 pods running. Okay. And throughout some of the lab, you'll see this other NFS client provisioner, the storage class and thing that we talked about and all that. So you can ignore those throughout the lab. We're just going to focus on what we actually did deploy. All right. So as you looked at this now, and again, you can go to the pods thing and look up that and get more details on that. But what we've really done now, and starting to get a picture of this, is we as a user ran kubectl. We created a deployment, and the deployment said to run a replica set of 2, and there are 2 pods always going to be running because of that. All right, so let's go on to the next step. Okay, let's go on to the next step now. Remember that we did a deployment of Nginx deployment, so we're going to drill a little bit deeper and now see, when we looked at the manifest file, we said here's what we want to have happen. Now let's go ask Kubernetes, how is it going and where did things end up and all that kind of good stuff. So let's go into that space. Clear the screen, and I'll cut and paste this command here. So I'm going to use the described from kubectl so I can see. I'm asking Kubernetes again, what's going on? And I'm focusing on that one thing that I just deployed. So you can see there's the name of the default, and it gives you dates and timestamps. It talks about the replicas, right? And that's part of the quiz. Are they created and running? Yes, again, just like we noticed a minute ago. 2 were desired, i.e. spelled out in the manifest file that we launched. 2 have been updated, they're total of there, and the status is available, so they're good. And you can see that there's no problem, there's none that are unavailable. You can see, like we found in the manifest, this is what we said to do, and sure enough, it did it for us. Okay, and then down at the bottom, like in the quiz here, it says what events have happened. Well, it actually does show you the events, and it says, I did what you said to do. I scaled up the replica set to 2, just like you asked me. So, ta-da, we did what we said, here's what to do, and it did what we said to do. All right, thanks, Kubernetes, and we'll go on to the next exercise. Okay, let's move on to the next exercise now, and we're going to start focusing on the replica set. We're going to kind of play a bad guy. And we're going to say, hey, can Kubernetes really keep up with what I asked it to do? So I'll clear the screen here, and let's go look at those pods again, see what's actually running. And you'll notice again, those are those 2 pods from that picture that are running as a replica set. We said to run 2 all the time, right? What if I put on that dark side and I'm going to say, nope, I'm going to kill one of those and let's see what happens. All right, so I'm actually going to use the kubectl command. I'm going to delete a pod, and you can either cut and paste this entry here. We're going to pick off that last one, or you can use command line completion. So we're going to get rid of that one that has the vnvd8. Okay, we're going to delete that. Let's see what happens. Okay, I got rid of it. What happened? What's Kubernetes going to do? I said to keep 2 running. What's it going to do? All right, so let's start querying things and see what the state of it is now. So let's get pods, and you can look at the pods that we had before running. Let's see what's running now. Oh, look, there are 2 running again. And you'll notice that this one is the same as this one here, right? So that's the original one that we did not kill. you'll notice that that one that I said, no, go away, it is gone. But you will also notice now that there is a second one that has come back. Okay, so Kubernetes said, you told me to keep 2 running, I'm keeping 2 running. And that's exactly what it did. All right, so let's look at the replica sets now. Yep, sure again. We said do 2, there are 2, and they're both in a ready state. And let's go ahead and do a little bit more detail on the replica set to see what we can find. Okay, again, the Nginx deployment is the replica set that's in consideration here. We said we wanted 2. 2 are desired, 2 are running. There's nothing waiting, so there's no issues with it. They're still running that same thing. But you will notice the events that have happened here too, right? You see that those were the original 2 created, and then you'll see this new one that got created. Okay, so we now have the ability, well, thanks to Kubernetes, to dictate what we want the final state to be like, and it makes sure that that state is what's happening. So now you have that inherent resiliency of microservices, and things happen very quickly because it is a container-based deployment. So they fire up pretty quickly, and you have those 2 that you asked for, and even if something happens, whether it's a physical machine went away, or the host went away, or something else went away, Kubernetes goes, you said 2, I will make sure that there are 2 always running, and it did that. All right. Okay, let's go on to the next exercise, and what we're going to focus on here is how do you manually scale things? So in Kubernetes fashion, there are multiple ways that this could be done. But let's say that we just want to manually scale up, and we want to say, hey, you know, it was awesome. We were doing 2 instances, but now we have enough workloads that we should have more than that. How can we do that easily? So clear the screen here, and we'll go look at, and again, you can click on the link to see the target manifest that we're going to deploy. But let's just do a diff of what we have deployed versus the one that's going to allow scaling. What really is the difference between those 2? Oh, look at that. So the old one, that's the original one we did, cites a replicas of 2, whereas the new one with the scale says, let's run 4. Okay, so we're going to double that. So that's the attribute that's going to be modified. Okay, let's go on to the next step. And what we're going to do is we're just going to validate what the current state is. And again, we'll just do the quick get the replica sets, because that's the parameter we said we're going to change. Let's make sure that we see what is the current state, and also the number of pods. And sure enough, we see the 2. Okay, that matches exactly what we started with that original manifest. Okay, on this step, let's go ahead and let's apply that new manifest. Again, the one that's up at the top there that says we're going to do replicas of 4. Let's just apply that. So just kind of say, now do this. Okay, and in the next step, we'll go validate and see if it did what it's supposed to do. Okay, so let's look at the current state, now the new state of what we just applied a deployment to. And we'll go check how many replica sets there are. And look, now we have 4, just like we told it to do, and they're all ready and running. And let's look at the pods and make sure that that took place. And sure enough, now you see 4 of those running. Now, the bonus quiz in this one is, how could you scale that back down? And just as a hint, you already had a manifest that had 2. Think about how you could just apply that and go back to that original state. Okay, let's go on to the next exercise here. And in this one, what we're going to do is we're going to, previously we were able to scale up and potentially scale down. What about if you wanted to change and you wanted to grab a new container image, right? You wanted to grab a new version, maybe it has a security update or something like that, or new functionality or whatever. What's an easy way that we can manually do that? So in this first thing, and again, you can click on this link and get to the manifest and see what it looks like in GitHub. But let's just do it again from the command line. Let's just do a diff of what we just had running. Remember, we had scale running. But now we're going to do something called update. So what is changed between these two? And you'll notice we actually changed a couple things, right? So which attributes are changing? Look, the last one we had said run 4. The new one says, oh, we're going to scale back down to 2. All right. And the old one had this version of Nginx, the 1.16.1. Whereas the new one, I said, no, go grab the newer one because that's cooler, has some functionality that I need, or like I said, might have security updates. Okay, so with those proposed changes, let's go ahead and validate again that the current state matches what we think it does. We're going to use the kubectl and describe and look at the deployment. And again, we see that, 4 as from the scale up, that's all there and running and everything. And yes, that has that image version from the original one. And also, when you look at the events, you can see, as before, that this has been scaled up to 4 from the original one, right? The original one had 2. We use this one to scale to 4, so that's our current state. Okay, let's move on and let's go ahead and apply this new version. I'm just going to do kubectl apply and grab that new manifest version that has those 2 changes that we talked about, the replica change, the image version change. And ta-da, it is done. Okay, moving on to the next step, let's confirm those expected results. And first thing we want to do is look at the deployments of the Nginx deployment and see if we get what we expect. So again, we said that the replica should scale down to 2. And look at that, it certainly did that. And look, it grabbed a newer version and replace those images, and I have 2 of the newer versions running now instead of 4 of the older ones. Okay. If we look at the replica set again, which is one of those attributes that we specifically changed, you'll notice that it did create. It deleted pods. It's created pods. Okay, there's the 2 that are running now. And then finally, let's look at the actual pods themselves. Okay, so let's look at one of them just to make sure. And sure enough, that image has been updated. So what we did is we were able to just, with a single, a couple changes in an ASCII text file and a YAML-based manifest, Kubernetes, we were able to make multiple changes, scaling down, changing image and version. It's just that easy with Kubernetes. And of course, if you wanted to downgrade the image version, you can probably figure out, oh, I could just go back and apply the very original manifest that I started this whole lab exercise with. That would scale it back, or that would move it back to that original version and then keep the replica sets the same as 2. There are other ways to do this as well. kubectl set or edit, you can do things like that. And then there's all kinds of automatic load scaling and things like that too. But that's it for this exercise. Okay, let's move on and let's go try some fun new stuff, some optional. As you've noticed throughout the lab exercises, and what we will continue to use throughout is with kubectl, which is a command line interface. It's very comprehensive. It has the ability to do that. And if you think of it very much like microservices, you can do things in a very granular fashion, right? I can apply something, I can get it, I can describe it, and we will show some more functionality later on as well. But sometimes people are not enthused by just running command line interfaces. And so what if there was more of a curses or a terminal user interface to do it? One of the things that you can do is, it's called K9S, right? And here's the web page and the GitHub site for it. Let's go ahead and install that and just play with it a little bit, just to give you an idea of something cool that's out there. And you can use this for the rest of the lab if you want, or you can just exist with the cut and paste of the kubectl commands. So I'm going to unpack that and then just figure out a little bit about some help and whatnot. Okay, so there's a bunch of stuff there. Let me go ahead and put more on the end of that. You can see that there's, we're going to talk a lot about this in the next lab, some of the other things, but there's lots of arguments and whatnot you can use. Let's look at an info command just to give you an idea. You can see that there's a config file that does this. It's keeping things in log, and you can do screen dumps and all that kind of stuff, which is really cool. As you'll notice in the lab exercise, there's a screen dump there. So let's go ahead and fire it up and see what it looks like. And this one is a little bit different version, but not too much different. And you can see that right off by default, it's showing me a deployment. Okay, well that's just what I did with kubectl get deployment, and that's showing me that. All right, there might be some other things that I can do. Let's see, and if you look on the man page and you look on the GitHub side, in fact, I'll scroll down there and show you that there's a whole bunch of the command line, the key bindings and whatnot. And let's say that we wanted to go look at the pods, okay? So basically colon and pod, because I can just get away. So even faster than doing the shorthand notation, I just do a colon pod, and I see those pods that are running. Okay, cool. Let me try and do the same with a replica set. And again, I'll cheat and use the shorthand, and ta-da, there. So now you have kind of a really cool, simple interface that's terminal-based, curses-based, that gives you a pictorial thing, and you can hop around and do things like that rather than very granular, do one thing very well with kubectl, a particular command. Okay? Okay, and as a reminder now, then of course you can go to that site again and look for more of the command and whatnot, but let's do a little bit of cleanup and stuff and get ready, and then we'll kind of cover some of this. But basically remember, this is the last one we did, which was that update manifest. Let's go ahead. Sorry about that. Let's go ahead and delete that. Let's make sure that deployment is gone. It's gone, and assumedly the replica sets are as well. And yes. And how about those pods? Yep, all of that's gone too. So now what you've done with this lab is you've launched a deployment. You've been able to scale it. You've been able to update certain components of it, and you've been able to delete it. And you also have a hint of another interface to kind of explore this. So we're ready to go on to the next lab exercise. All right, welcome back from lab 2. Let's do a little bit of follow-up. So, and this will be my terminology for it because of my long background of using Unix and Linux for decades now. And kubectl is a command line interface. It is my best friend to deal with Kubernetes, and it's always the fallback. You saw a terminal user interface and whatnot that you could do. There are web dashboards, or it's a Kubernetes dashboard and things like that. So you can ease others into it easier this way, but I wanted to make sure that you understand kubectl. And again, manifests in that yet another markup language, or YAML. That's the simplified way to interact with kubectl. Okay, that's how you can create, it's how you can modify, it's how you can delete, and as you notice, they are flat text files. So it is extremely easy to go ahead and put those into a version control repository, right? So now you have the ability to contribute that, and your peers can leverage that in a very easy way, pointing at a specific version that you know is working. So again, this is all very straightforward to accomplish, but I'm hoping that with the next lab that you're still curious. Okay, let me go a little bit deeper. Okay, let me go a little bit deeper and understand more. And that's what we'll try and do next. Okay, let's talk about lab 3. So cruising down the highway. What are we going to cover here? Basically, we're drilling down to another level of the architectural stack. We're going to talk about additional components and functions, who can use what and how. So in other words, you know, if you've heard about containers, you know, you can run potentially thousands of containers on a given host or something like that. If you think about seeing that output in some of the commands that you just saw in the previous labs, that would be overwhelming. But there are ways to segment that and make that visible for what you need to see. Then also there's more container attributes and things like that. And finally, we're going to spend some time talking about the cluster nodes, the cluster roles, okay? And we're going to take advantage of these operational aspects for your workloads to kind of move things around and try things. Okay, so let's look at the logistics for this lab 3. Again, you're going to stay on your student workstation, you're going to SSH to the access node, and you're going to spend most of your time using kubectl. However, if you start to look at this picture, you can see what's been filled out underneath the fact. In this case, your student workstation is actually a Linux KVM host. It's hosting a bunch of virtual machines for you. Those virtual machines run various roles within the Kubernetes cluster, and you'll see that in the lab, and that'll be explained more. And it offers on that access node, it offers things like a storage class to give you persistent store through those virtual machines. And when you're running things, it's actually pulling those container images from outside. Okay. So this lab will take a bit longer. There's a bit more to go through and whatnot, a bit more to explore. And again, I would encourage you to click on the links that are references for any of the things, read about that if you get some time. And also in the advanced and optional exercises at the end, there's multiple pointers to things that you can go learn next. Okay. All right, let's move on to the final lab, and we'll work down the exercises. Again, the goal of this one is just to drill a bit deeper, learn more other Kubernetes functionality and objects, and drill down into actually the physical, the cluster, and everything that's running all this stuff. So let's jump to the first exercises. One of the things that you'll want to learn about is namespaces, and there's a link here, and you can go learn about that. It is a way to basically provide virtual cluster spaces for people to deploy their own stuff. So let's take a look and see what namespaces are running on the cluster right now. And looking in the quiz, where do you think all of your workloads landed before? And I'll give you a hint. And if you look at this namespace called kube-system, what do you think resides there? As a hint, think about all the core underlying Kubernetes things that are making all this possible that you're interfacing with. So let's go on to the next step then. Okay, in the next step of the exercise, let's look at the manifest that we're going to deploy and see if we can figure out some things of where it might land. So this should look very familiar to the one that we used in the last lab exercise. Again, has the replicas of 2, the old version of Nginx, but I don't see anywhere where it's calling out a namespace. So where do you think it would land if we actually deployed it this way? I'll give you a hint. Okay, since it wasn't dictated by the manifest, let's go ahead and say we want a target to land in a different space. I'll go ahead and clear the screen here. We're going to create a new namespace. And we'll call it the Handson Lab 1289, which matches this lab exercise. Okay, that was easy to create. Now, unlike the last lab where we just did this part of the deployment, we're going to say, no, make it land in that namespace. And there you go, it is done. All right, so let's go query and see, did it actually happen what we think it should happen? So let's go look at the namespaces. And sure enough, there is a namespace and it is active and it's been up for a few seconds. Okay, since we just launched it, it makes sense. And if you want more detail on the namespaces, you can go to that link and see that and learn about that again. If you want to see the deployments that are in that namespace, you can see now, because we're not using the default, let's target just seeing what's in that namespace. And sure enough, there it is. And likewise, remember we had replica sets that were called out on the manifest. Let's look there in that namespace and see if they are there. Sure enough, 2 were desired, 2 are ready and running. And let's look at the pods and see if those are in the namespace. And they are. So it was simpler to deploy that generic manifest and target a new namespace. Very convenient. Okay, let's go on to the next step in this exercise. And let's look at it and just make sure that if I don't specify the namespace, that it isn't there and it's not visible. And sure enough, there is no deployment by that name in the default namespace because I didn't specify what other namespace. It fell back to the default. So I wanted to make sure that you understand this and just realize that in this lab environment, you were given admin privileges for the Kubernetes cluster, and that's all a function of the kubeconfig that's underneath all of this. The kubectl command knows how to access which cluster with what user and all that stuff. You were given admin access, so that's why you can create things and then do whatever you need to for this lab. But there is a very granular set of role-based access control. And if you're interested in that, to learn that, that's a very big topic, but it's very granular. You can specify that Joe can create namespaces, but Jane cannot. Or Jane can create deployments in that namespace, but can't muck around with the namespace. You can do all kinds of things. Very granular. So let's go ahead and clean up this deployment now. So remember, we're going to delete the deployment and we're going to be very specific about that namespace. Okay, it's gone. Let's validate that it really is gone. Yep, sure enough, no deployments are there. Let's go ahead and clean up the namespace. And that will be gone here in just a second. There we go. And let's go ahead and look around and make sure that there are no namespaces left around that we left beside. Sure enough, HOL-1289 is gone. We are done. Okay, let's move on and look at the next exercise. Go ahead and clear the screen. And we're going to talk about storage. And this is one of those areas that if you're talking truly cloud native and whatnot, the notion is that everything runs stateless fashion and whatnot. But in reality, there are a lot of containers and microservices that do need some persistence or at least some data to be able to read and write while they're running. And storage is the way to do that. As mentioned in the slides earlier on, there is the notion of a container storage interface. And there are multiple drivers out there. There are just a bucket load that you can do and apply. So you can connect lots of different storage devices to your Kubernetes cluster. What we're going to start with, and we're going to look at what was already deployed for you. And I'll give you a link here to the Kubernetes storage class, which is what we're going to focus on now. Here's where you can learn about it. But let's go ahead and look on this cluster and see what storage classes are there. Okay, you see that one is there, and when you're looking at the quiz, based on the naming, you know, what protocol do you think we did? And I'll give you that hint. That's probably the answer right there. Okay, so we used a network file share to do this. This storage class was actually pre-deployed for you on the cluster as part of the cluster deployment via a thing called a Helm chart. That you can explore that later on in some of the optional advanced exercises later. But you'll actually find that there's a directory on this node that has where the content is being held. And we'll go through that in just the next steps. Okay, on this step, what we're going to do is launch a set of components and basically another deployment kind of thing that's going to leverage this backing store, and each other's actions will also be interacting between the two, the pods and whatnot. Of course, you can go look at this manifest, but you'll notice that I'm using the -k, so I'm actually using a customization thing. So let's go ahead and deploy that. And you'll see it calls out a couple of things here, a persistent volume claim and a replication control. And we've already talked about replication sets and whatnot quite a bit. So let's go ahead and go on to the next step and start to learn about that persistent volume claim, kind of like we saw in the very first lab. All right, with persistent volume claims, and again, you can follow this link and look at this up and whatnot. And it talks about volumes and persistent volume claims. Goes through all that thing. Let's go ahead and take a look at what got deployed. You can see that we have a name called NFS PVC, okay? And it is bound, so that's a good thing. We know that it's actually working and whatnot. But what we did with this deployment is the actual NFS server is the same node that this Axonus node is running on. So if we were to list the directory that's being served, it looks like this. And you will notice that we have a persistent volume claim called this, and you'll see that there's a directory there with that same thing. So that's actually where it's being served from. That's where the content going, and that's how things are working. So we've kind of seen both sides of the coin, what the pods are doing and what they're using of it, and then actually what's happening underneath the covers from the storage class that's providing that. We'll go into some more details here next. Okay, on this step, let's dig in just a little bit deeper now. What we're going to do is we're going to look at the pods. So I'm going to go ahead and clear this screen off. We're going to see what pods, and then you'll see in the notes on the lab guide that I called out the NFS BusyBox and whatnot. And you could have reviewed that and found that. In fact, we'll go ahead and do that right now by looking at those pieces. And you can see, yes, it is called NFS BusyBox. And it does connect that persistent volume claim there. All right. So what we're going to do next is we're going to describe that pod. And I'll go ahead and use the command line completion. And we'll pick that last one. Okay, and let me run that again and pipe it to more so we can scroll through it a bit. Okay, so you can see again, that's the name of that and we can see that it's actually running a command within that pod, and we'll get to that here. If you look at that, it's actually running this looping command of running the date and creating it into a file, and running and also echoing the host name and running that into that file. Then it sleeps for a random amount of time and continues going through that loop and whatnot. Okay, so that's the command that's being done. But where is it mounted inside the pod? And you can see that it's actually mounting it in /mount from that persistent volume claim, and it's mounting it in a read-write fashion so that it can do that command over and over and over. Okay, so with that said, let's go on the server side behind the storage class in that directory /public, and let's look at what's happening to that file. Let's just watch and see if we can see those updates happening. You can see there's a date stamp there, there's a host name there, and hopefully here in a few seconds, yep, you can see that the other pod came along and did. Now the first pod did it, just cycling back and forth and doing that. Okay, so let's go ahead and quit out of that. And one of the things that I wanted to show you next is how do you interact with that microservice, that container that's running inside that pod, and start to act like you're in that space. So again, let's do this. And we'll pick that same thing, same one that we did before. And I'm just going to run a simple command just to see the output of that mount point. So I'm just running the df command. And you will see that that mount is there, and it is tied to that persistent volume claim that we covered earlier when we did the get of persistent. And you can see it's actually coming from this host /public / that mount point. Okay, so now you've completed the cycle of, you know, where it came from, how it's being used, and what's being updated and whatnot. So you can use this exec-it and then run a command, and it could be a shell if you wanted to run, you know, if the pod and the image supports that. You can run a specific command there. You can interactively integrate it, or you can just run a command like I did and exit back out. Okay. Okay, let's go on to the next step of this exercise then. I'm going to go ahead and clear this screen for you, and we'll go to this. So what we're going to do is, you know, not only can you interactively deal with a pod and a microservice that's running, but sometimes you might want to figure out, you know, get logs and see what's happened in the past and whatnot. And that's beyond the events that you might see in the describe. So let's go see what pods are running. And you know what? Let's go after the storage class this time. So let's go get the logs from the storage class. And let's look what's been going on with that. And remember that we've done a lot of things with it over the course of the entire set of labs exercises before this. So you're going to see, you know, provisioning happening, you're going to see things started, and you're going to see things deleted and whatnot. In fact, you know, you can see the MySQL stuff that happened in the past, and you can see all of the steps that were going on. So I can see that log. And you can see that one that was created at the very end that's running right now is provisioned successfully, and it's still happy in a known up and available running state. So when we go to the next step, we're going to go ahead and clean up that deployment and whatnot. If you were to go back and review the log at that, you'll see that it got deleted and cleaned up and archived. All right, so now that we've gone over the storage information and whatnot, let's go ahead and clean up that deployment. And we'll do it via the -k of the delete kubectl and just point it at that customized patch. And Remember that it's deleting the persistent volume claim, the persistent volume. It's archiving it just like those other ones that we showed when we listed the /public. It's going to take just a little bit of time to clean that up. And it's got to get rid of those multiple pods that are reading and writing all the time. So it's just going to take a moment. And there we go. It's all done. It's all cleaned up. So now we can move on to the next exercise. Okay. So as mentioned in the slides before we started this lab, that there is a significant amount of infrastructure that's behind the scenes that we haven't had to deal with. But now would be a good time to understand what you've been landing on top of. What's that foundation that's existing? So we're going to look at the Kubernetes infrastructure underneath us. So let's go ahead and clear this window. And we're going to start with a simple layer, kubectl, and we're going to look at the cluster info. And it calls out something called a master. Okay, we'll learn about that in a minute here. It does have some DNS or domain name service that's running as well. And that's how you access and how, as things are flown up on the fly, how things interact with each other and how you reference them. Let's look at the config view. All right, so you can see that there is some information about that we have an admin, and that's certificate, and that's how we're interacting with this cluster. And you also see that there's a server with a specific port that we're interacting with. All that's behind the scenes of the kubectl and the kubeconfig file. All right, and one more thing. Let's go ahead and see if we can start to get a glimpse of the nodes that are running this cluster. And you will notice, oh, look, there's that master that it was talking about. Yep, that does kind of match that. There's a couple of worker nodes, and that's actually where all of the specific workloads that we request, that's where those land by default. And the master is the one that does that scheduling and watches for those things like the replica set. You said you wanted to have this many running. The replica set will make sure that across the workers there's that many running. If not, it takes care of the problem for you. Okay, and as noted in the tip, you can get a little bit more information if you run that command with the -o wide option. You can see the status. Not only that, but you can see what version of Kubernetes is running, what their IPs are, what the container runtime is, what that version is. You can see what operating system it's running, what version, and all that stuff. The kernel. You get a lot more information, but you can suffice with just the Git nodes. And we're getting ready to go and drill deeper onto the next step. All right, let's drill a little bit deeper now, and we're going to use the same kind of command that we did before, which is kubectl describe. But now we're going to talk to a node. In fact, we'll look at the master first and see if we can learn some stuff. So as we start to scroll through and look at this, we can see a lot of information about it. And we'll keep scrolling down. And remember, some of the stuff we could actually see in the -o wide information too, but this one even goes a little bit farther than that. So looking at the quiz, we'll pull out a couple of things. What kernel version? So you can see right here, here's the kernel version. What about the container runtime? And we saw this in the wide thing, but you can get it here as well. And also you can look at some of the pod information about, things like that. And the question was how many of them are running, and that's 10. And then also, remember when we talked about namespaces, what's in that kube systems namespace? Well, there they are. Those are the pods that are running. Like the one we saw on the API in the config view is the core DNS. Okay, that's running there. There's the kube proxy. There's All of these things are running all the time, and Kubernetes takes care of making sure that those are running as well. So now we've seen kind of the master, and that's the one that you interact with to schedule things, and that's what keeps the orchestration happening for you. So with that done, we'll stop there, and then we'll go on to the next step and look at another set of nodes. Okay, let's move on to the next step in this exercise, and let's go work on and take a look at the worker node. Okay, so clear up the screen, and we're going to use that same command, but we're just going to focus on the worker 0 node. And remember that this is where all of the user requested microservices are potentially running. In this case, we've cleaned up all of the lab exercises before, so there's not much there. But there's a lot of information about these nodes that can help us later. So just like before, you can certainly look up kernel and whatnot. But one of the things that you might want to also look at is, the capacity. How many CPU cores or virtual cores are there? How much ephemeral storage, that I can have the images that I'm going to deploy on that when they land there and actually are running there, obviously the image has to be there in order to spin it up. That's what the ephemeral storage is for. The next thing is memory. How much RAM is there? Okay, so we can see that from a capacity perspective, what's there. And then also from an allocated perspective, we can see how much of it is fair game. So if you were to cordon off, but if you were to specify a certain amount of it can be used, then this would be potentially quite a bit different. And you'll see that they are slightly lower because some of the Kubernetes resources are running there. So they've taken up those pieces. So that's why this is allocatable. And then you'll notice there's a set of container pods that are running on this worker node in that kube system namespace, okay? And those are the ones that are needed to interact with the master and also deal with whatever you want to have launched. So there we go. We've looked at the master and the worker. Okay, so now let's kind of give you an overview of the cluster itself in this implementation that we have here. So I'm going to go ahead and clear the screen off and scroll down, and we'll describe some of this picture and whatnot. Of course, you can go to these links that are included in the lab guide, and it talks about the components and whatnot. But like I mentioned, there's the master that has that control plane aspect of it, and that's how you interact with it, right? So that's what's doing there. And then the Kubernetes nodes, the worker nodes, are over here on this side, and they have a few processes that just interact with the master to deal with what you want to do, plus maintain Kubernetes itself. So if you want to see another representation of it, it might look something like this. Again, kubectl is how we interact with it. It goes into that API server, and it might do a deployment, which goes to the controller in the deployment, which might generate the replica set. So this is sounding very familiar, right? Like the very first deployment we did, all the way down through the pods. etcd is basically a name value database where the configuration of the cluster is maintained, and also things like I need to have 2 of these replica set pods running. That's maintained outside of it, so in case nodes go away or come back, you still have that information. And then what happens is it does the scheduling, which goes to the kubelet and whatever container runtime engine is there, and spins up those containers for you. And then there's also aspects of watch and health and things like that to let Kubernetes know that, ooh, one of those pods failed, it's part of a replica set, let me fix that problem, blah, blah, blah. Okay? So if I were to go back now to the student workstation, so I'm going to exit out of the access node. If I were to do this command to see that actually all of this stuff is running as virtual machines, and you can ignore this one for now, that's outside the scope of this lab exercise. But you can see the admin node, which is actually the access node that we've been on this whole time. There's the master, there's the worker, and there's the other worker, okay? And if you wanted to, you could also go to the graphical user interface from the desktop and see that same thing there. And if you were to open that up, you can also see the resources that we're due, and those should map into those same kinds of capacities and whatnot, okay? So, bottom line, and this goes back to the slide that you saw before we started this lab exercise, we actually have a set of virtual machines that are running on your student workstation that provide the master functionality, the two worker functionalities. Container images were pulled from outside, and you were interacting with this almost dominantly with kubectl, okay? And when Kubernetes needed storage, it would go out to that access node, which provides the NFS server and have a persistent store that it could leverage and whatnot. That gives you the entire picture of this cluster and how you've used it over the course of, from the very first thing of a customized deployment all the way to manipulating specific storage aspects, doing namespaces, things like that. So with that, we'll stop there and go on to the optional and advanced exercises and just discuss those. Okay, so for the optional and advanced exercises for this is more of a homework assignment for you. Hopefully that everything you've learned so far has really intrigued you to the point of you really want to start using this and learning about more of it. So first thing is you can go back and learn just about Kubernetes and then look at the website and figure things out from there. Another thing is to go down the path of the Cloud Native Computing Foundation, which is about how to create workloads, right? And the notion of all of those things that you're doing within the Kubernetes space and how you can leverage all that stuff. This is a really good site. As we mentioned earlier, the storage class that we set up ahead of time for you so that you could leverage it and use persistent stores and whatnot on the back end, that was done via Helm and with a Helm chart. I would definitely encourage you to go do this. This is like a very easy way to leverage somebody else's expertise and just launch a complete service in your environment using a Helm chart, and it's literally as easy as Helm install application. Okay. Finally, there is another thing called operators, and this is very much like the second lab section where we were doing scale up, scale down, and changing images and whatnot. You can basically just run that operator, which has all of that information, and then you just take one little thing and you can have the operator manage that, and you don't have to apply anything. It'll just do all that stuff for you. So it's a very operational thing of if you have a production environment and you just want to make a new container images because your developers did something really cool, you can just pull that in and away you go. So with that said, with this lab, now we've covered a lot more of the Kubernetes layers, including like namespaces as a way to kind of create virtual environments for people to play in without having to see everything that's running across the cluster. They can just focus on what they're doing, or you could do a dev QA test kind of approach with that. We talked about storage components because stateful microservices are something you need to do, and it may not be that you want persistence, let's say for like a database to last over an infinite amount of time, but you might need to have just storage to interact with, to read data in, do an analytics thing, and write the results out or the metadata out or whatever. They can either be persistent or archive like we were doing. Then we also showed how to interactively go into a command line within a microservice pod that's running, how to access those logs so that you can see the history of it, which is incredibly valuable for the operators and also for the developers, right? Because they can see, oh, I see a glitch of somebody else is trying to access me in this way, therefore I need to fix that. But just seeing those logs over time of, this happened at this time. Oh, I didn't expect that. Or, oh, cool, that did do the right thing. So why did that pod not do what it's supposed to do? And then finally, that whole notion of what the resources are, what the attributes of it. So with this, we've kind of done that introduction to Kubernetes. We hope that we got your interest up. We hope that is something that you want to do. We hope this is something you can play with. And with that, I'm going to go ahead and stop, and we will summarize the overall environment, overall session. Alrighty, welcome back from lab 3. And let's go through the follow-up, and that was the last lab for this session. Again, kubectl will probably be your best friend for quite some time. It's the one command that you need to know and interact and do everything with, okay? It's not the only way to do things, but it is one way that you can pretty much do anything you want. Again, YAML, that syntax is how you do with manifest. And also, if you spend some time looking at Helm and Helm charts, you'll see that those are also written in YAML, as are operators and everything else too. That's how you control how you interact with Kubernetes, okay? It's a very stateful representation of what you want to have Kubernetes manage for you. And finally, hopefully now you're aware of some of the cluster resources. And granted, this was a smallish cluster, all right? It only had a single master and a couple work nodes. So it's certainly not a production grade cluster, but it's enough to do pretty much anything you want to, especially with that little storage class add-in and whatnot. You can pretty much do anything you need to do. So again, it could be that student workstation was a laptop in front of you. It could be your laptop in front of you. You could have this entire environment running on your laptop and do all the development and do all this testing and whatnot. And then when you're ready, just launch those manifests at another Kubernetes cluster. And you can do that with kubectl and just the kubeconfig that designates how do I get to that other cluster, okay? So what you've done is pretty impressive. You started off with a very simple deployment. Then you've drilled down, and you drill down yet again in lab 3. Okay, well, I hope you really enjoyed the labs. I hope that was very useful for you. I hope you can now take advantage of some of the resources that we're providing to you. You can certainly go to these links in this presentation. You can grab the hands-on lab materials. The Kubernetes distribution used was actually our SUSECON platform. There is a deployment guide pointer, a training pointer there, or you can do things, and again, this is call out to Alex, what he did. We created a set of Terraform scripts to launch an entire Kubernetes cluster on a given system with one command. And those are links to the GitHub. If you don't like Terraform, or if you want to try it another way, some of our services and consulting guys have come up with a way to do it with Vagrant if you're running on top of KVM as the only target on a given system. So you can try either of those and deploy this entire environment. And when you look at the GitHub site that has the hands-on lab materials and whatnot, you'll find pointers to some other things and other resources, including all of this lab and the videos. Each one of the lab exercises has a distinct video that you can look up and hand off to somebody else and let them look at it and get them interested in it. And then, of course, you could use these reference points to go ahead and set up your own cluster or whatnot. Alternatively, you could use things like OpenSUSE Cubic, which is our community distribution, and it is a Kubernetes compliant and distribution, and it's easy to set up. In fact, you can do a single node Kubernetes cluster, kind of like you could do with Minikube. Minikube by default does it as a VM on a host, or you can do it with bare metal, but OpenSUSE Cubic can either do that same thing, and it's pretty easy to set up and run as well. So you have lots of choices you can go and play in this space. In addition to those references, I want to point out some other things that you might be able to find on the SUSECON Digital. There are business overviews about containerization and whatnot. There are technical tutorials. Those are all the references there and whatnot. And there are other hands-on labs. One of the other hands-on lab that's entirely complementary to this is how to run and set up a SUSE platform cluster that runs Kubernetes and whatnot. That's one of those other hands-on labs. But go to those sessions, go to learn it. If this piqued your interest, go take advantage of all this material. You can do it virtually on whenever you want. And that's the awesome part of this. So with that said, I want to thank you again for joining us at SUSECON Digital 2020. I really appreciate you joining us. I hope this was useful. Feel free to reach out to us if you have any questions, you want some guidance, you find issues. Again, a lot of this stuff is on GitHub, so a pull request would be more than welcome. Take a look at that. And if you have any desires or needs, please feel free to reach out to us. I hope that you enjoyed that introduction to Kubernetes. You learned a lot. It piqued your interest, and you'll just go on to the next level and have fun. Take care, all. Bye.